Dr. Babasaheb Ambedkar Open University.
Welcome once again. We are here for software engineering video lectures for BCA-403, right? And we were looking at block 2, unit 3, where we have already done in the previous session user acceptance testing, the steps of UAT, right? We have already seen what are the process, what is the process that we undergo for UAT, right? Then we have seen quantified user acceptance testing. We have already seen what is verification, validation for my software, and we have seen lastly was grey box testing, which is mixture of my black box and white box testing, which is translucent one. All right. Today, in today's session, we will see is non-functional testing. All right. What is non-functional testing? What are the parameters for it? We will be seeing software performance testing and load testing. What are the types of load testing? All right, and how those load testing help me to analyze the performance of my software. And lastly, we will be seeing is test artifacts. Right. Let us start with today's session. Non-functional testing. Non-functional testing in software is related with non-functional requirements. All right. So very first thing that they are actually my non-functional requirements and is mainly designed to find the readiness of system based on certain criteria that are not included by functional testing. So it is not something what we say as a functional testing. In functional testing, we check on the functions that my particular product is going to give me, right? But unlike my functional testing, here we'll be focusing is on my non-functional parameters, right? It is seen that non-functional testing allows to measure and compare testing results of non-functional attributes of software systems. So all my non-functional attributes of my software system will be tested into non-functional testing, and we actually see whether my all those non-functional requirements which were there, okay, which were levied down, all those are being fulfilled in my software or not. Will be checking on that. It can be seen as testing of an application or system against client's requirement or performance. Whatever my client is expecting, all right, whatever the requirement my client is having, whether it is meeting that particular, it is reaching to that performance level or not, comes under non-functional testing. Here we will be seeing that we have various kinds of non-functional testing. Now here we will be seeing there are certain examples of non-functional testing. We will be seeing certain examples. I will be discussing out one after the other. Alright. Well, first one is performance. Let us first see the list of the entire thing. Then the second one is security. I will explain later on. Third one is usability. Fourth is reliability and dependability. Alright. Then we have is endurance. What is endurance? I will come back to that. We have localization and internationalization. Then we have ergonomics. We have installation and configuration of the product, compatibility and interoperability. Now what it says is my particular product, all right, has certain features. There are certain examples of all right. First is performance. It says that when my particular product is, it is being developed, whether it is meeting a particular performance level or not, whether it is performing good or not. All right. So to check that performance, we have performance testing. Then we have security. Right. Whatever product I am developing, I should be sure, it should be secured enough for my end users. If my end users are feeding some data into it, and if that data is thrown out on the internet to everybody, then that shows that my particular product is not secured, right? So we check on the security. Then usability, whether my product is going to be usable every now and then, or what is the usability ratio of it. All right. Then reliability and dependability. As said, if my product is secured, my end users will be reliable on it. But if my product is unsecured, it is not secured at all, then in that insecurity of my product, you will, my users will not rely on that. So reliability and dependability also, comes from the security, and whether my performance is proper of my software or not, then only my users will be dependent on them, right? So reliability and dependability. Then endurance. All right. What is the endurance power? If my particular software is failing up, right? What is the endurance power of my software to pass out from that failure stage, all right? Localization and internationalization, right? It says that whether my particular product is locally available, it is giving me a local result also, and it is, it can take up the international level also or not. Then ergonomics, where can my software be used, what kind of environment from where it can be used, what all environment it will not be working on, all right? Then how many people will be using it actually, and how many people will not be using, all comes into ergonomics. Installation and configuration, when my particular software I am using, I'm going to deliver, I have made it, how can I install it, what are the configuration that it will require, right? Then compatibility and interoperability, which says that whether my particular software which I have developed is compatible with any system, all right, or it needs a particular system only with a particular configuration only, and whether it is interoperable at different platforms. For example, I have developed it for Windows, in Windows, right? Whether that particular software will work in Linux framework also or not is called as interoperability and compatibility and interoperability. Then maintainability and availability, which says that when I have actually given up, all right, given my software to my customer, all right, after this stage, right, it says that when I have given a software to my customer, how will I be maintaining that software? Maybe after 2 years I need a maintenance to that software, all right, then it comes under maintainability and availability, whether every time my software will be available 24/7 to the users, if required for maintenance, whether it will be maintained properly or not, comes under maintainability and availability. All right. So, these are the examples of non-functional testing. So, all these parameters, that is non-functional parameters, will be checked upon into my at the end of my product, at the final phases of my product. Then all this, if we are meeting up all the requirements that are there, if we are actually seeing all the requirements, we are meeting up all the requirements, then we say that non-functional testing we have passed, right? The next topic is software performance testing and load testing. Here we will be seeing that there are several types of load testing, there are several types of performance testing, all right, and what are those types, I will deal it in detail. In software performance testing, a non-functional technique which is done in order to locate the system parameters which could be related to responsiveness and stability under different workload. It says that it is a non-functional parameter. Performance testing, load testing are non-functional parameters which will check that if my load increases on my particular software that I have put, all right, or I have configured, that software if has an increment in the load, whether it will be able to perform well or not, whether it will give me the same result when it had a proper load or maybe when it was under load, and when it is overloaded, whether the performance is getting degraded, what is the percentage of degradation it is having in the performance, or that will be checked upon in my particular this kind of testing. It says the performance testing measures the quality attributes of system which could be scalability, reliability and resource usage. Alright, my particular product when is undergoing a performance testing, it will actually see to 3 different parameters which are scalability. Scalability means if I am going, for example, when you are, let us say that you have to sing in front of one person. Now, when you are singing in front of one person, you will be performing really good, alright, because you know that person. Now, you are supposed to sing in front of 2 people, you can still sing well, but now you are supposed to sing in front of thousands and thousands of people. Will you be able to perform well or not? So, scalability says that when you increase, when you work with one system, that is okay, you work with 2 systems, it is okay, but the same software works for thousands of systems. Alright, scalability, that means increased number of users, alright, then in that case whether it is able to perform well or not comes under scalability. Then reliability, as said that my particular product, if I am using, I am the only user, it will give me good result. If I have 2 users, it will still give me good result, but when I have lakhs and lakhs of people using my system, my software product, alright, whether it is giving the same result to everybody or not, can we rely on that or not? And resource usage. if I have one or two people using, my resources will be utilized less, right. But if I have lakhs and lakhs of people, my resources will be utilized more and more. Resources yani the hardware resources, right, whatsoever the network resources are there, all those resources usage will be increased a lot. Then what about the performance? Alright. So on basis of these three attributes, we actually measure the quality of my performance, we measure the quality of my software product based on this three, right. It says the idea of performance testing, what is the reason behind it, is to measure the features like response time. What is the response time? Okay, for example, if somebody, I said the previous example only, if somebody asks you to sing, alright, and that person is very known to you, you will probably start within a second. But if there are lakhs of people and you are asked to sing, you'll at least take 1 minute of hesitation, right, that how to sing. Alright. So that kind of hesitation is called as response time. There you were able to, when there was only one person, you were able to respond in just a second, a fraction of second. But when you had lakhs of people, it took 1 minute to respond, right. So it checks on the response time. It checks on the throughput or mean time between failures, which depends on different ways. Alright, throughput or mean time is something where you actually get the output. Alright, maybe you are failing into it and then you are getting the result. Alright, that is throughput. And using tools like profile activities, timing delays and related different parameters. So here the main reason behind performance testing are definitely two things. One is the response time of your product. You will come to know that when it is responding, and you will come to know what is the exact throughput, what is the exact result or the outcome that you are getting, and what time it took, maybe with the failures also, what time it took to achieve that result. Then it is noted that if the performance testing is not up to mark, it is noticed that if you fail or maybe it is not up to mark, then some analysis needs to perform in order to see where problem persists and what measures are to be taken to improve it. If you are not actually happy with the performance testing, the performance of your software, then it says that you need to increase, or you maybe need to analyze your software code. You need to incur some sort of functionalities maybe into your software, alright, in order to reach that performance level. It says features or characteristic of performance testing tools are, now there are various tools available for performance testing, alright. What are the features required for it? First is testing of generate load on the system. So what we do is, we have to, because we have to check the performance, we are supposed to generate load on that system, on that software, right. So first is we have to generate the load on that particular system. Then measuring the timing of particular transactions with varying load on the system. Now it says that previously when your system was working, it was working with 100 people. Now generate load on it. You generate load from 100 people, you move it to 1000 people. Alright. So what is the measure of performance it is giving at that particular time? Now from 1000 you increase it to maybe 10,000 people. So now what is the performance, what is the, whether performance is degrading, whether performance is up to mark or not, comes under measuring the timing of particular transaction. Then measuring the average response time. What is the response time that you get when there were 100 people, when there were 1000 people, and when there are 10,000 people, whether the response time is same or not, alright. Plotting the responses over time graphs or chart. Now whatever response you are getting, you plot it into the chart or a time graph, and you will come to know that when there were 100 people, response time was very fast, maybe, right. When there were 1000 people, response time was same. When 10,000 people turned up, maybe response time was delayed by maybe a fraction of seconds or so, right. So that there is a degradation in the response time. You plot it into a graph and you will come to know where your performance is lagging down, right. There are certain techniques involved in performance testing, such as, now let us see each testing techniques. First is my load testing. Now load testing is something where it checks on the performance, alright, it checks on the performance under required load conditions. It says that my particular system was able to handle maybe 1000 of people. I said, for example, I have built up a system which is able to handle 1000 people at a time. Alright. Now what I do is I check by increasing the load. I check it for 100 people, then 500 people, then I check it for 1000 people, and when I say 1000 people, whether the same performance is given when there were 100 people working on the system, whether the same things are achieved when 1000 people are working on the system, whether it is matching or not, comes under load testing. Results in measuring of critical business transactions, database load and application servers and etc. Right. So, it tells that how much now when 100 people were working, database was not having much load, but now when thousands of people are actually working in the same system, so thousands of people working on the same database, then my database will be heavily loaded, right. So, that particular measure helps me to understand my load testing. Second is stress testing. Now, what is stress? If you simply understand in a normal English language, stress is nothing but a tension, right. What we sometimes we undergo, like in exam we are stressed. During exam we don't know how we'll be working through our units and all, right. So, during exam we are tensed. So, stress says that testing is done to know about upper limit capacity of system and also to find out how the system will react when current load moves above the required maximum limit, alright. So, for example, I can handle one subject during one day for writing a paper, right. Now, similarly, if somebody asks you to appear for exam of 2 papers on the same day, right, you will be stressed. Which paper to work on? First paper I should work on first, second paper I should work afterwards, how much, right. So, that is something when you get stressed, it will check that how much is the upper limit of your load testing. For example, upper limit of my previous system that I discussed in the previous example was 1000 people, right. Now, it will check stress, it will increase by 1100, that is 1100 people on my particular system. Though my limit was, upper maximum limit was 1000, I increase it by 100, alright. Then how is my system going to respond, alright. That comes under stress testing. Then next kind of testing is shock testing, alright. A form of endurance testing which is done to find the system parameters under continuous expected load, alright. If I continuously give the same load to my system continuously, for example, though its maximum limit is 1000, I give it continuously with 1500 of users every time, alright. So, 500 is the a stress testing, right, wherein I am actually having 1000 of them, which is my upper maximum limit, but I give 1500 users the same system. Then in that case it will check whether my particular system is able to understand all the system parameters like what it was giving for the 1000 people or not, comes under shock testing. So, it is a form of an endurance testing only. Then spike testing, it is done by increasing the number of users by large amount, thereby measuring the performance of the system. So, here what happens is, previously my system was working fine with 1000 people. In spike testing, we increase the number of users very high. For example, 1000, okay, it can work. I increase it directly to 2000 or 3000 or 4000. So, there is a very it shoots up like anything. The users who are using the system, it increases like anything, then we call it as spike testing, and thereby we even actually check the performance of it, that at 1000 people it is working good, but if I increase it to 5000, whether it is performing the same way or not is called as spike testing. Then of course, again the load testing, it is done by increasing the number of users by large amount, thereby measuring the performance of the system. It is one and the same, right. Now, what is the goal behind this load testing, right? What is the reason, what is the actual idea behind load testing? It says the main aim of load testing is to highlight the defects or errors, alright. It will highlight the defects or errors that exist in my software code which occur in application due to buffer overflow, but buffer overflow means overloaded users, alright, overflow of the users, alright. Then memory leaks and mismanagement of memory. Now, what happens is, if for example there is one single hole, okay, in that hole the capacity of people intake is 100. Now, if I can accommodate easily 100 people within a hall. Now if I said there are 200 people to be accommodated in that 100 hall, then probably few of them would be sitting on the staircase, alright, few of them would be sitting near the stage area, alright, and few of them would be sitting in between the rows of the chairs, alright, and that is how I actually accommodate them, right. But if I still increase it to 300, then it is overflow. I cannot accommodate 300 people into the capacity of 100 people, right. So in that case, my load testing is very helpful to make me understand what is the defect or what are the errors inside my software. Then the load testing will find the upper limit of components of application such as database. It will come to know that how much my database can hold. For example, my database can hold 1000, that is its upper limit, that's it. It can hold thousands of it. Again, I do spike testing 2000, yes, it can still hold 2000 people, its upper limit is 2000. And hardware and network in order to handle the anticipated load which could occur in near future. So it will help me analyze that how much maximum people I can accommodate inside my database, work with my network, work with my hardware, alright, and that maximum limit, it will be helpful only by the, that maximum limit we will be able to achieve only by the load testing, right. Now the last topic of this unit is test artifacts, alright, and it is one of the easiest one. It says test artifact is a scenario where a product what was developed in various phases of software testing lifecycle is being shared with owner or a user. So it says that it is an artifact is a scenario, a kind of a a real kind of picture where whatever is developed inside my product, I mean inside the software, whatsoever the functionalities are there or whatever is developed, I share that particular life cycle, the software testing life cycle and everything, these scenarios, alright, with my end users or my owners, then it is called as artifacts. Such artifacts gets prepared by software test team. My software testers will be preparing those artifacts, which takes final sign off from owner or user just to make sure that there exists no communication gap among customer and testing team members. So my testers whatsoever they have tested, alright, the test cases and everything will be given to my owners, alright, and they give those test cases to the owners in order to in order to minimize the communication gap if at all it exists, alright. This artifacts help in tracking the changes which occurs during the testing process. So whatsoever changes that comes across, for example, my customers needed something XYZ functionality, that XYZ functionality is not there in that test case, alright, then my customer can demand for it again, right, that I need this XYZ facility which is not provided by your software, so you kindly give that or provide that particular software functionality. Then it helps to track the changes, alright. So now you need to again remodify your code, right. So modification of that code, what we are going to do, alright, is something where we need to track it out, alright. So that is also done with the help of artifacts. It says there are certain deliverable test artifacts, alright. We have certain deliverable test artifacts such as test strategy, alright, what was the strategy behind this testing, alright, how much for example, how much was it required, how much the testing of this particular item was required or this particular unit was required, alright. So test strategy is built up. Then we have test plan, alright, what was the test plan of it. I cannot directly start with testing, no, it needs to have certain plan layout, alright, and after that planning of testing only I have to actually undergo the testing, alright. Then we have test scenarios which says test cases, a kind of test scenario which is for example, my particular unit 1 maybe the particular product is made up of different modules, right. So that first module which I have already prepared, what are the test scenarios within that module, alright, whether for example registration form, login form, right, then the security part, everything is checked or not, comes under test scenario. Test cases, right, every scenario will have a test case, whether it is going it will have parameters, different parameters listed, that what all parameters are there, it will be checked. If those parameters are actually checked and if they are passed, it will say the test case is passed, alright. If it fails, then we say test case is failed. If it is a failure, then we have to give it back to our developers that you have not undergone a test case properly and you have to modify the code. So, test case is there, right. Testability matrix is there, alright. Testability matrix says that I have tested this particular product. Now, this particular product which I have tested is how much is it testable, how much is it testable, right. If my test that I have done is 100% testing I have done of the product and I have achieved that this particular product has passed 80% of the testing, then we say that my particular product has testability matrix of 80%, wherein it is lagging behind by 20%. So, for those 20% I have to change my product code, or the developers have to change the product code, alright. Test report is there. After testability matrix, that this many parameters are done, these parameters are passed, these parameters are failed, we have to generate a report. A consolidated report is generated, alright, where we even talked about reviewers, if you remember in the previous unit, right. So, a reviewer will check all these things, alright, and a reporter will be there who will generate a report, alright, and this test report will help me analyze that whether I have passed a particular testing criteria or I have failed a particular testing, alright. So, test report is there. Now, before we move to the other points, let us examine that I have a particular software, alright, a software named as A. Now, this software A I have asked my customer, they want some 10 functionalities into that software A. Now, those 10 functionalities, out of those 10 functionalities, my testers will be checking for all those 10 functionalities, but out of that we have found that we are providing them with 8 functionalities. 2 functionalities we are lagging behind. So, for those 2 functionalities, that particular product, that particular test report and everything is built up, and we give it back to the developers that we are lagging behind by 2 functionalities. You have to redevelop your code or you have to modify your code in order to include those 2 functionalities also, so that in order to that my particular product, my particular customer is getting all those 10 functionalities whatsoever they need, alright. So, all this this is a kind of an example, and this artifact will help you to give a particular idea, an exact picture, alright, to you as well as your end user. As a tester, if you are there, it will give you a perfect idea that whatever product I have built up, whether it is lagging behind in some or the other parameters, alright, and it will help you lower down or minimize the customer, the communication gap that you have with your customers, alright. So, it minimizes that too. Now, let us summarize what we have done in this unit 3 of block 2, wherein it was all about user acceptance testing, the processes, alright. Let us sum it up. We have seen is, in this unit we have learnt is user acceptance testing. We have seen the steps for user acceptance testing also. Now, in order, just in brief I would tell, user acceptance testing is nothing but a kind of a beta testing, alright, or maybe a kind of an acceptance testing, or we can even say it as an end user testing, right, wherein we are not, we as a developer are not going to check it, we as a tester we are not going to check it, but some people or a group of people outside my organization will be testing on my system or my product that I have developed, alright. Then we have seen the process that is involved in user acceptance testing. We have seen QUAT, which is quantified user acceptance testing, which will check on the whether the particular testing has been met or not. It will check on the quantifiable parameters, right. Then we have seen is software verification and validation. We already know what is verification and validation. It deals with the software testing. The entire testing is dealing with verification and validation only. If my product passes the verification stage and the validation phase, then I would say my software testing is proper, right. Then we have seen as grey box testing, which is, again I am repeating, it is a mixture of my black box and white box testing, where I will be knowing only the partial things of my internal structure or internal data structures that I have in my product, alright, and it is a kind of a translucent one. and we have seen is non-functional testing. What are the parameters for non-functional testing, starting from performance, security, reliability, and all those stuff, right? Then we have seen software performance testing and load testing. We have seen the types of load testing, wherein we have seen spike testing, we have seen what is the kind of an endurance testing, all right. All those comes under load testing, all right. Then we have seen testing artifacts. We say it even as test artifacts, which says that what to remove the communication gap between a tester and the customer, all right, wherein my testers would have checked upon the particular product and they have prepared a test report, and whether it is whatever they have tested it is correct or not is coming under test artifacts, which is actually approved by my customers, right. So this unit was all about user acceptance testing and the test artifacts that we have seen, all right. We have even seen the types of load testing. In the next session we will be going through block 3, that is unit 1, and block 3 is all about software risk management, right. Let us meet in the next session. Thank you.